am Vijendra, and today I am going to discuss with you a small topic in fluid mechanics, which is very commonly used topic. Okay, it's a very simple topic, I'll say, and very commonly used in written exam also and interview also. It is covered, and the topic is I'll say Bernoulli equation and its various variants in which Bernoulli equation is used, and how we make use of Bernoulli equation for various questions. Now, Bernoulli equation actually is the equation of conservation of energy. But as you know, Bernoulli equation comes from Euler's equation, and Euler's equation is the equation of motion. Now, let me tell you, as fluid mechanics is a basic subject for mechanical and civil engineers, both for written exam and interview also. This is an important subject. So I don't think there is any interview in which if you say fluid mechanics is your favorite subject, he will not ask you from Bernoulli equation. Certainly he is going to ask you from Bernoulli equation. Now let me tell you, Bernoulli equation, to make Bernoulli equation, first you need to start from Euler equation. Now Euler's equation is the equation of motion, and there are three terms here. I'll tell you, dp by rho is one term, v dv is another term, plus g dz is third term, and that is equal to 0. That is called Euler's equation. Now, if I go a little back, then fluid there are some forces, and those forces are analyzed to go for the dynamic analysis of the fluid flow. Dynamic and kinematic analysis. Dynamics is nothing but forces, and kinematics is nothing but flow characteristics. Now Euler studied two forces. One force is the pressure force, another is the gravity force. So somebody ask you, Euler ने कौन-कौन सी forces को study किया? I'll say that is the pressure force and gravity force. These are the two forces studied by Euler for studying the motion of the fluid. Now in this equation, can you tell me where is the pressure force? This particular term is the pressure term, pressure over density. This term is the gravity, acceleration due to gravity. Then what is this third term? What is the meaning of that? You will say, sir, this one is the output, inertia force. If you go to second law of Newton, you know this second law of Newton. Second law of Newton says, sir, external force applied is equal to rate of change of linear momentum. So I'll say if this is input, this is output. Similarly, these two forces, pressure and gravity force, these become the input to get output in the form of fluid kinematics. And what is the fluid kinematics? This VdV, or this particular velocity, whatever is coming, velocity of the fluid flow, that is the kinematics part. So this is a dynamic part, this is a kinematic part, you can think of that. So in the interview, he is going to ask you, write the Euler equation. And you have written the Euler equation. Then he's going to ask you, what are the forces involved in Euler analysis? You will say, sir, two forces, pressure and gravity force. They are the most significant forces in the fluid flow. Then you will say, but terms are three. These are the two forces. What is this force? Sir, this is the resultant of the forces. You can call it inertia force also, or this is the output part of the two forces. And in these terms, we can calculate fluid kinematics. Now, when we draw this equation, then there are some assumptions. When we draw this Euler equation, there are some assumptions, and these four assumptions are true for Euler equation also and for Bernoulli equation also. Now, what are these four assumptions? Number one, fluid is inviscid. Inviscid means viscosity of the fluid is 0. That is ideal fluid. There is no fluid which has 0 viscosity, but we assume the fluid to be having ideal fluid to be having 0 viscosity, and such fluid is called inviscid fluid, or whose viscosity is 0. Second is incompressible. Now you know what is the meaning of incompressible? Incompressible means density is constant. Density is constant, or the change in density is 0. Such fluid is called incompressible. Liquids are incompressible, like water is incompressible, which has constant density. Third is assumption is the steady flow. You know what is the meaning of steady flow? Steady flow means rate of change of any particular parameter with time will be equal to 0. That means there is no variation with respect to time. That is called a steady flow. That is the third assumption. And the fourth assumption is irrotational flow. Fourth assumption is irrotational flow. So omega terms, that is rotational terms, will be 0. Omega x is 0, omega y is 0, omega z is 0. So these are the four assumptions by which we make the Euler equation, and Euler equation is the equation of motion, and there are two forces involved, and these forces leads to the fluid kinematics. Now where Bernoulli comes, you see Bernoulli is the energy equation. Number one, you remember Bernoulli may assumptions of the Bernoulli equation are same as the assumptions of Euler equation. These four are the assumption of Bernoulli equation also. And second thing you need to understand, Bernoulli equation is obtained when I integrate the Euler equation. So how do you get Bernoulli equation? Sir, I get Bernoulli equation by integrating the Euler equation. So if I integrate Euler equation, this is what I'm going to get it. Now let me give you now equations what we get here. So if I integrate these equations and with the assumptions that rho is constant, this particular term will be P2 minus P1 by rho plus, what is the integration of this? I'm putting the values also, V2 square minus V1 square by 2. Integration, you know, V dv integration is V square by 2, and the limits is V2 square minus V1 square by 2. And what is the integration of this? G into Z2 minus Z1 is equal to 0. This is what the Bernoulli equation is for me when I integrated the Euler equation. Now let me now write this particular equation in different ways. Let me write this way. Sir, P1 by rho G, P1 by rho, sorry, V1 square by 2 plus G Z1 is equal to P2 by rho plus V2 square by 2 plus G Z2. If something at state 1 is equal to something at state 2, if these terms at state 1 is equal to these very terms at state 2, don't you think I can write then generally that sir P by rho plus V square by 2 plus GZ is equal to constant? Don't you think I can write like this? So this becomes my Bernoulli equation. But you know the most important thing, I told you that sir Bernoulli equation is the equation of conservation of energy, equation of conservation of energy, and energy is measured in kilojoule or joule. But do you think every term is measuring the kilojoule? Answer is no. If you see, the potential energy is mgz, but in this case it is gz. So don't you think this is the potential energy per unit mass? Kinetic energy is mv square by 2, but this is the v square by 2. Don't you think this is the kinetic energy per unit mass? And similarly, this is the pressure energy per unit mass. That means what I get is P by rho plus V square by 2 plus GZ is equal to constant. That is actually written in terms of energy per unit mass, and that particular thing is called specific energy. There's a term called specific energy, and that term simply means energy per unit mass. So once you write this equation of Bernoulli, that means it is written in energy per unit mass. But let me tell you, there is another term, very popular term, in which the Bernoulli equation is written, and that is the term in terms of head. What is the meaning of that? Now let me manipulate this equation. P by rho G, V square by 2G plus Z is equal to constant. Let's see these three terms now. I divided throughout with G. Can you tell me the unit of each term here? And remember what is dimensional homogeneity. That simply means that if one term has dimension of meter, every term which is added or subtracted in the equation will have same dimension. So Z का dimension क्या है? Meter. तो इसका भी क्या होगा? Meter. इसका भी क्या होगा? Meter. How do we remember that? Don't you know hydrostatic law? Do you know what is hydrostatic law? Yes sir. Hydrostatic law say pressure at any point in the depth Z is equal to rho into G into Z. Pressure at any point depth Z in the fluid is rho into G into Z. And what is rho G? Sir, rho G is the specific weight, is the specific weight of that fluid. That means weight per unit mass. And if the weight is mg, and if I divide weight per unit, sorry, volume. So if I divide that weight with volume, mg by volume, it becomes the rho G. That becomes the specific weight of the fluid. So pressure at hydrostatic pressure at any depth Z is rho G Z. Now can you divide P with rho G? What do you get? P by rho G is equal to Z, and that is the reason P by rho G has unit of Z. That means in this equation of Bernoulli, every term is in meters. Every term is in meters. This particular thing is called pressure head. This thing is called pressure head. This thing is called kinetic head, whereas this thing is called datum head. This is called datum head. Now why this equation, and more popular equation is this Bernoulli equation. He will ask you to write Bernoulli equation. First you write this equation, then you write this equation, and he is going to ask you why do you write most of the time this equation in terms of head. What is the significance of that? And for that we need to go to actually the application part of the fluids. You know, fluids have statics, kinematics, dynamics part. First we go to statics part. Sir, whenever the fluid is there, it has energy in it. If you take the example of reservoir or dam, water is there in the dam. It is not flowing, it is there in the dam, but it has a power. When the water is kept at height h on the top of your roof, it has a power, and that power is in the form of datum. That is called gross head, or whatever you call it. The fluid has power in this form. Now at the bottom of that fluid, if I give you the example of a reservoir, let's say this is the reservoir, this is the building, or this is the dam we have created, let us say, and fluid is stored on one side of the reservoir, let us say this. Then if the fluid is stored up to depth z, it has a pressure in fluid here. Rho gz will be the pressure in the fluid here, and that fluid pressure will eventually convert into velocity, which is equal to P is equal to rho gz. So if I use the Bernoulli equation, I can calculate velocity also. V square by 2g is equal to z. So 2gz under root will be the velocity of the fluid once it starts flowing. So sir, initially the fluid was having energy in the form of its head, gross head. That can be converted into pressure. That can be converted into kinetic energy. So directly in terms of z, we can calculate pressure. How? P by rho g is equal to z. So what is P? Sir, rho g z. Directly we can calculate kinetic head, say what is the velocity. So V is 2gz under root. So why do you write Bernoulli equation in terms of head? Because sir, in the beginning fluid has energy, or fluid has power in the form of head. When we store that particular fluid, from that stored fluid I can calculate directly pressure of the fluid, I can directly calculate the velocity of the fluid flow in terms of head. So these terms directly can be used to calculate velocity at the exit of the nozzle and pressure at the bottom of the reservoir, if I know that the fluid is stored up to z depth in the reservoir. So is the question clear why you write Bernoulli equation in this particular form? That is the question is going to ask you. Now I come to third part. He is going to ask you, do not write Bernoulli equation in specific energy term. Do not write in terms of head. Write it in terms of power, kilowatt. Because I want to know what is the fluid power I have. What is the fluid power? Now, can you tell me what should I do if I want to get power from energy? This is the energy, kilojoule. This is kilojoule per kg. And you know what is kilowatt? Kilowatt is kilojoule per second. That is kilowatt. So what should I do to this kilojoule per kg so that it becomes kilojoule per second? Sir, I should multiply it with kilojoule per second. Kilogram per second, sorry, kilogram will get cancelled out and I will get kilowatt. So 1 kilowatt is equal to kilojoule per kg into kg per second. And what is kg per second? That is mass flow rate. That is called mass flow rate of the fluid. And can you tell me how mass flow rate is related to discharge or volume flow rate? So sir, density into discharge. Discharge is meter cube per second and density is kilogram per meter cube. So if I multiply kilogram per meter cube with meter cube per second, I get mass flow rate. That means if I multiply this equation with mass flow rate, yeah, with rho into q, rho q is discharge, volume flow rate, then I get equation in the power terms. So let me now make the power term out of this. So I write this rho into q, p by rho, plus rho into q v square by 2 plus rho q g z is equal to constant. Certain things will get cancelled out. P into q plus rho q v square by 2 plus rho q g z is equal to constant. This is the third equation of Bernoulli written in kilowatt form. And always remember, fluid power is calculated as rho qgz. This is the fluid power. Fluid power, you know, you people study something which is called fluid machinery also. Have you not heard Pelton turbine, Francis turbine, Kaplan turbine? Now all these turbines are installed on some particular fluid power basis. Now if suppose head is very high, then Pelton turbine is used. If discharge is very high, then Kaplan is used. If head and discharge are moderate, then Francis turbine is used. Now fluid के अंदर what power is there, on the basis of that you will use some turbine. Now in this particular formula, rho into G is basically fluid property, that is constant. That means fluid power either depends upon Z or depends upon the Q. Either the fluid will have more head. If Z is more, use the Pelton turbine. If discharge is more, use the Kaplan turbine. So fluid power का formula क्या है? Rho Q G Z. उसमें rho into G क्या है सर? Specific weight. And Q and Z क्या है? Fluid power depends upon Q and Z. It will have lot of quantity, like Ganga river in Allahabad or in Uttar Pradesh में whenever it is flowing, it has more discharge. Ganga river in Uttarakhand, it has more head in that. So either Z is more or Q is more. That is the term which we are to use. So these are the three forms in which Bernoulli equation is used, and we can use the Bernoulli equation for different situations. Now to end up my lecture, this small video clip which I made for you, let me tell you one thing very clearly. Bernoulli equation is conservation of energy equation, but which energy? We are only talking about three energies: pressure energy, kinetic energy, potential energy. These all are called conservative energies. So far we have not told about the friction energy loss. That means loss of energy head in the form of fluid friction or viscosity, because assumption was the fluid is not real, it is ideal, it is inviscid. But suppose we use the real fluid, suppose kya, every fluid is a real fluid, so viscosity losses will be there. In that situation, how to write Bernoulli equation for real fluids? Bernoulli equation for real fluids: P1 by rho G plus V1 square by 2G plus G into Z1 is equal to P2 by rho G plus V2 square by 2G plus Z2. This is the equation written for ideal fluids. When we say all these three energy terms is equal to all these three energy terms at 2 points, and there is no energy loss. But a real fluid may there will certainly be energy loss, and that is always calculated in the form of loss of energy head. And this loss of energy head is because of fluid friction, viscosity, etc. There can be other minor losses also which we'll study later on, so that can be energy loss. So if suppose we say write the Bernoulli equation for real fluid, this is how you have to write it. And you know the most advantage, what is the best benefit of writing Bernoulli equation for real fluids? We will get to know what is the direction of flow. When fluid flows, if HF is positive, suppose in this question HF is positive, that means all these three energy terms are more than these energy terms. You understood that what I said? If this is positive, that means these energies are more than these energies. That means all these conservative energies at state 1 was more, and these energies left in state 2 is less. Where the other goes? Other goes in the friction. So can you tell me the direction of flow? Sir, it is 1 to 2. Energy at 1 was more, energy at less second state is 2. So rest of the energy is lost when fluid flows from 1 to 2. But suppose in this equation HF is negative, then that means energies at 2 were more, energy at 1 is left. That means fluid is flowing from 2 to 1. So this is the way you can tell direction of flow of fluid. I hope something is clear to you. I have covered this particular topic of Euler and Bernoulli from both written exam perspective and interview perspective. I have tried to make you understand the concept. Euler mein what are the forces, that is from where we started. Euler is equation of motion, what are the assumptions. From Euler, how you get Bernoulli equation, what are the three forms in which Bernoulli equation is written. Bernoulli equation for real and ideal fluid, how do you write that, and certain questions that where is energy here and how do you write it in power and what is the meaning of fluid power. Those things we have covered here. I hope this small concept is clear to you. I'll come again and cover some small another mechanical engineering clip or civil engineering clip with you to make you understand that small part. Fine. Thank you.